People have used air pressure for thousands of years to turn windmills, to move sailboats. It is air pressure that lifts airplanes into the air and keeps them there. It's the force that drives tools and machinery, and when it's used in braking systems, it will stop heavy trucks and even trains. You use air pressure every day in your work with Dowell. Machines and equipment that carry hundreds or even thousands of pounds of pressure are sure to get your attention and respect. This program will demonstrate to you very graphically that any amount of pressure requires your attention and respect. Before we go further, let's take a look at the word pressure and make sure we know exactly what it means. An engineer will tell you that pressure equals force divided by area. You might think of force as being a push. That push is then divided by the area over which the push is applied to determine pressure. The amount of push or force an object can bring to bear is equal to the pressure times the area over which it's applied. We can express that idea with this equation. Force equals pressure times the area it is applied against. Can you see how a small pressure pushing on a larger area can create a large force? Here's a more practical way of illustrating how you can get a big push from a low pressure pushing on a larger area. Consider a sailboat. This toy boat has a total sail area of about 300 square inches. Just a moderate breeze generates a pressure of about 1/10 of a pound per square inch. By using our engineer's formula, we can see that such a breeze would exert about 30 pounds of force on our toy boat. That would be more than enough to move it through the water. Now consider a larger sail. A sail about 20 feet high and 10 feet across would create an area of over 14,000 square inches. The same moderate wind pushing across this larger area would produce over 1,400 pounds of force. This is more than enough force to move this sailboat, and it's more than enough to create a serious threat to safety if not properly controlled. This sailboat demonstration is an example of how a small pressure acting on a larger area can become a very big push. This is an example of why you must always respect pressure of any size. If you lose that respect, you could lose your life. In Dowell, you are often exposed to the low pressure, large force situation. This happens when you use pressurized bulk equipment. To demonstrate the danger posed by low pressure, Dowell produced a training film called "Don't Tease the Tiger." This video showed the potential danger our employees could be exposed to whenever they worked with pressurized bulk equipment. Demonstrations were arranged using Dowell equipment to illustrate the awesome power of air pressure. While some of the images and uniforms look a little dated now, the demonstrations are a graphic reminder of the constant threat. In the original Tiger, an analogy was drawn between air pressure and a tiger. You can cage a tiger, it said, but you can never tame one. Air pressure is a tiger in Dowell. We can contain it, but never tame it. It is and always will be a constant threat. Today, decades after the making of Don't Tease the Tiger, Dowell employees still face the danger, and tragically, we continue to have horrible accidents involving air pressure. This program was produced to make sure you don't forget the tiger. You encounter low pressure in bulk trucks and various location vessels, such as silos. The pressures involved are far below those encountered in stimulation treatments and pumping service, but you must respect the potential this equipment poses for serious injury or death. You must never drop your guard. Low pressure can be just as deadly as high pressure. Importantly, that respect must translate into clearly defined work habits and a commitment to follow procedures exactly as they're written. For example, thousands of people have hit thousands of pressurized silos hundreds of thousands of times and nothing has happened, at least not at that moment. Hammering on a silo chips off the protective paint. This allows spot corrosion to begin on the exposed metal shell. This spot corrosion can cause small pits in the metal, reducing the strength of the steel. Hammering on a silo can cause an imperfection in the steel that's already under stress from pressure. Hammering is like scratching or scoring a piece of glass. Makes it easy to break. If you hammer on pressurized equipment, you have lost your respect for air pressure. Never use a hammer, even a rubber mallet, on a bulk material storage vessel. At the facility, you can determine the level with your hand. The best way is to use the weight reading on the load cell of the tank or the weigh-batch blender. When on location, you can determine the level with your hand. While discharging material, you should also monitor the pressure gauge and watch the discharge hoses. When the bulk tank is empty, the pressure will drop off sharply, and the discharge hoses will begin jumping around due to the slugs of air moving through them. Another rule essential to protecting yourself is never, absolutely never, work on a vessel that is under pressure. The company has suffered several accidents over the years involving air pressure. Each of them has been severe. Frequently, the victim was trying to correct a leak by hammering on the hatch or opening a hatch on a vessel that still contained pressure. Always respect air pressure. Never assume anything. Don't assume the pressure gauge works. Don't assume the relief line is open and unobstructed. Remember, just a few pounds of pressure remaining in a bulk tank can concentrate enormous force on a large area like a tank hatch. A hatch cover can become a flying chunk of steel, damaging anything or anybody that gets in its path. If you must perform any work on a pressure vessel, you must first make sure there is no pressure in that vessel. The following procedure must be followed. Check the pressure gauge and make sure it's reading 0. Do not rely only on the pressure gauge, however. Open the vent line slowly. You may feel air venting through the valve. If possible, look for indications of venting where the vent line ends. Open the delivery or load line as another way of making sure a line is open. Check the pressure gauge again before opening the tank. Release the retaining bolts near the hinge first, then release the bolts on the other side of the hatch. Never stand in front of the hatch when you are releasing the retaining bolts. Try to stand off to the side opposite the hinge. Proper maintenance and regular inspection of bulk equipment and safety relief valves is critical. Make sure you follow the requirements of Safety and Loss Prevention Standards 18, 27, and 28. Standard 18 contains a checklist that should be used to audit bulk equipment. Another key procedure you must follow to protect yourself involves the use of third-party equipment. We do not usually use or operate third-party equipment. If we must use third-party bulk equipment, the checklist in Standard 18 must be used to audit the equipment before it is put into service in Dowell. Third-party equipment used by Dowell employees must meet the same standards as Dowell equipment, or it cannot be used. As long as you respect pressure, even very low pressure, you will comply with all these requirements. You will not hammer on vessels. You will not work on vessels under pressure. You will follow procedures for bleeding off pressure, and you will use the bulk equipment inspection checklist. Because if you lose that respect, you could lose your life. So, why does someone knowingly violate the rules just given? Why does anyone expose themselves to the danger of air pressure? Well, here's what happens. Sometimes hatch covers or valves or connections start leaking under pressure. It causes problems and delays to stop an entire operation for repairs. Sometimes people assume that gauges work properly or that the pressure's already been bled from a vessel. They don't respect the pressure, and sometimes they pay dearly. Not long ago, a man noticed air leaking from a hatch cover, and he climbed to the top of the silo to tighten the wing nut. The silo contained about 35 psi, but that small pressure applied about 24,000 pounds of force on the 700 square inch hatch. When he struck the first blow, one of the bolts broke, and instantly the remaining bolts gave way. The hatch struck him in the head with over 10 tons of force. We don't like to think about it, but the man died a terrible death. In another event, recreated for Dowell cameras, a man was removing a hatch from a silo he assumed had been bled off, but a line was plugged. It only contained about 5 psi, not much pressure. But when he loosened the last bolt, well, watch in slow motion at what 5 pounds of pressure did to a mannequin. In this event, the man was not killed, but he did suffer numerous broken bones and internal injuries. He spent agonizing weeks in the hospital and longer still recovering. In another event, a man was loading cement into a silo when he heard air leaking from the hatch of the bulk trailer. He climbed up to the top of the trailer, and while trying to reseal the hatch, the cover blew off. The safety relief valve on the third-party trailer was found to be non-operational. However, because the relief valve on the Dowell compressor was working, there's no reason to suspect that the pressure inside the trailer exceeded normal working pressure. The man was blown over 15 feet away from the hatch opening. He laid in the sun for over 5 hours before being found by Dowell personnel, concerned by his extended absence from the district. While the man was not killed, he suffered total irreversible paralysis from the waist down. We witness incredible feats performed by air pressure on a daily basis. But don't let yourself be endangered by complacency. Respect the power that even low pressure contains. Never hammer on vessels. Never work on a vessel under pressure. Follow procedures for bleeding off pressure and complete the bulk equipment inspection checklist before using any third-party equipment. Air pressure is a powerful tool that is an essential part of our daily lives. We use it and witness its strength so often that sometimes we forget just how powerful it can be. We know all too well that air pressure can be a terribly destructive force. If we take shortcuts, make assumptions, fail to follow procedures designed to protect us, air pressure can be a killer. So which will it be? A tool or a killer? It's in your hands. Don't forget the tiger.